Let's talk about one of the most powerful and beginner-friendly tools in machine learning, decision trees. Whether you're just starting out or refreshing your skills, this video will walk you through how they work, why they matter, and how you can use them in real-world projects. At its core, a decision tree is a model that uses a flowchart-like structure to make decisions. Each internal node asks a question about a feature, each branch represents an answer, and each leaf node gives a prediction. Imagine you're trying to decide where to eat. First, you ask, is it open? Then, is it affordable? Each of these questions narrows down your options. That's exactly how a decision tree works in machine learning, using data-driven questions to arrive at an outcome. A decision tree has a few key parts. The root node is the top of the tree, the first feature we split on. Internal nodes or decision nodes represent feature-based questions. Branches are the outcomes of those questions, and leaf nodes are the final predictions. Now, how do we decide what feature to split on? That's where splitting criteria come in, like Gini impurity, entropy, or information gain. These measure how well a feature divides the data. Let's break down the process. The algorithm starts with the full dataset. It calculates the best feature to split the data. Once split, it recursively repeats the process for each resulting group. It keeps going until one of these happens. All data points in a group belong to the same class. We hit a predefined maximum depth, or we run out of features. At the end, we have a tree where every path leads to a decision, and each leaf node makes a prediction. This structure is both powerful and interpretable, making it a favorite for data scientists and educators. So, why do people love decision trees? They're easy to understand and visualize. They handle both classification and regression tasks. They don't require scaling or normalization, and they work well with both numerical and categorical data. But there are trade-offs. They can overfit, especially when the tree is too deep. They're sensitive to small changes in the data, and they may not perform as well as more advanced models like random forests or XGBoost. To fix these issues, we use techniques like pruning, setting a max depth, or moving to ensemble methods. Decision trees are everywhere. In healthcare, they help doctors diagnose based on symptoms. In finance, they're used for credit scoring and loan approval. In marketing, they help segment customers. And in agriculture, they predict crop yields. Their interpretability makes them a great choice when decisions need to be explained, whether to a manager, regulator, or customer. Here are some quick tips to use. Decision trees like a pro. Use cross-validation to catch overfitting early. Set limits like max depth or minimum samples per leaf. Visualize your tree. Tools like Scikit-learn make it easy. And when accuracy matters, try ensembles like random forests or gradient-boosted trees. That's a wrap on decision trees. I hope this helped you understand how they work and where to apply them. If you found this video useful, give it a like, hit subscribe, and drop a comment if you want us to cover random forests or gradient boosting next. See you in the next one.